guys. This is about this startup called LLM Says So. When AI speaks, we prove and verify. You see a little asterisk over there. So we're not going to verify the LLM execution. We're just going to verify the origin. So we prove that the response came from an LLM provider. So here's a little look at the architecture. So we have like 4 areas in the architecture. So the agent environment, and we have the LLM provider, which is labeled as LLM Says So, and we have the smart contract. So the agent environment has the agent itself and LLM Says So SDK. So everything starts by agent making a request for an LLM response to the LLM Says So SDK. Then it asks LLM Says So API, and LLM Says So queries the LLM, prepares the heuristics that are required to make the proof, and then it just sends back the response with the heuristics to the SDK, which passes it over to the agent. Now, agent requests some on-chain operation, and LLM Says So SDK, it's too long to say, I'll just say LLS for now. So LSS prepares the commit, LSS SDK prepares the commitment for whatever operation was requested by the agent and sends over the proof of origin as well as the commitments required to verify that the correct response is being executed. It verifies the origin, verifies the commitments, and then performs the on-chain operation. Any questions about the architecture? All right, then moving on to the demo. Oops. Wait. So this is the interface. Here we have some agent context, which is not going to change very much. And here we've got some prompts. We could say, this is a basic one, so we could just say, I don't know, like swap something or something.
Yeah. Can you zoom in?
Yeah, sure can. Is it visible?
Yeah.
There's a reason I've got this terminal over here, which we will find out about soon enough. So this is our agent context. It's like a DeFi instruction parser. It specifies this is the output. You should give me the results in, very precise. And it also specifies what the valid operations are. And by default, this is some default in case I fuck up the prompt and it doesn't know what to do. So I say by default, try to use USDC as the second token and ETH as the first. And the output should not contain anything, blah, blah, blah. Your typical agent, instructions on how the agent should behave. Then I say swap, one WBTC for, some stars maybe. Then we just send it to the LLM. It takes a second because, we got the response under here now. There's some thinking involved, but we don't really care about the thinking to keep things efficient. We just try to do the verification over the response. So now I'm going to try to verify the origin, which is rather simple. And you can see that here the origin was verified. And more importantly, we also want to verify the commitment on the response. So let's try to do that. So a bunch of stuff happened here. There was a slight delay. You might have noticed it, like it goes boop, 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 instead of boop and everything. So because it's trying to do some verification right on the client tier, which will actually be done on the smart contract. So we're trying to we expect some specific decommitment based on the heuristics provided by LLM Says So. First we check that the signed root matches, and it does, of course. Then we, So we just create a new commitment based on the data that we have. And finally, this one should match perfectly the expected decommitment. So there's the proof is verified. So, yeah, basically that is pretty much it for the demo. Any questions? Yes?
Why do we feel we need to modify the origin?
Oh, we need to verify the origin because like you can have, anybody can make a commitment. Even when you decommit, you need to still make sure that the commitment was not made by an arbitrary party. You want to make sure the commitment was made by a specific party that you trust, which is in this case going to be the LLM provider.
Any use case?
Agents, because like if you have like, of course there are a lot of use cases, but around DeFi especially. But let's take a more revolutionary use case. Let's say you have an autonomous world and you have an agent which is supposed to make sure that in your world there's a consistent ratio between certain resources. And you notice that the players are cutting a bunch of trees and there's a price increase of trees in the market. That's irrelevant. But then now this agent gets this instructions. Just a second here. So it's going to have some instructions here. But there's also another field that I haven't added here, which takes in the context, like as in like what's happening right now, which is going to affect its thinking. And there you could have like the new ratios, and then you could decide what to do to, you know, make the ratios better again. So then this will have to go onto the autonomous world contract, and it's going to have to spawn more trees into the world. So this thing, we don't need the agent to just like say whatever it wants to say. We need this. We want to make sure that it's actually coming from a commitment. Also contains a commitment to the agent context. So you're going to verify if it is the correct agent context. And you might want to verify what prompt it was, maybe or maybe not. But so that all comes under decommitment part. Yes.
To me, this seems more useful in like a more controlled environment again, where there is information which the agent has access to,
Yeah.
which you don't have publicly, and it is a verified access to, but it is not publicly available, but it has been shared somewhere within the system, and it needs not, or else if it's just completely open, I don't know how it looks at noise to signal ratio.
So that is not the responsibility of LLM Says So, that's the responsibility of the LLM. What we typically do is we have an LLM which is going to sit there and chat with the user, and then that LLM does not have these strict instructions, but it's more conversational. And then from the conversations, we then pass like it to another LLM query, which is gonna take the chat that you had and it's gonna figure out, do I have an instruction here that I can parse? If I can, then I'm gonna parse it. So that is the layer you might wanna use this layer at. So it's gonna be a public agent, so to say. Actually, it could be a fully autonomous agent.
It has a different from like a critic agent.
What's a critic agent?
Usually defined as something which if there is some material, yeah, it is.
It might be the same.
Yeah, it's the same. Technically,
Okay.
it's the same.
Cool. Any other questions, guys? All right, so that's a wrap. Thank you very much.